Hi there, it's time for lesson 9.3. This is Mrs. Trombley, of course, and another method of solving quadratics, completing the square. So you have learned how to factor to solve. You've learned how to graph. You've learned how to use square roots. Now we're going to use something called completing the square. And eventually you'll build on this in some of your other classes in your future. So this is kind of your introduction to this method here. Okay, so remember back in polynomials when you were given, and I know this is a little unclear, I found a typo before I started recording, this should be a 4. When you had an example of a polynomial like this and said, oh, well, this is a perfect square and this is a perfect square, and 4 divided by 2 is 2 and 2 squared is 4, so it works, we could write it like this. So we had those little special rules that we had learned about. Well, what we're basically going to do is when you're given an equation in the form of x squared plus bx, we're going to find a value of c that will make this a perfect square so that we can write it like that. Because we learned already how to solve equations in x squared equals d form. So we're kind of putting what we did before with the square roots together. So it's like a 2-step little process. So I think this isn't going to make much sense until we start working through some of the examples. So the best time to use this method is when you have a quadratic equation in the form of x squared plus bx. And how you do this? Well, first you make sure it's in the form of x squared plus bx equals some number d before you start. And then I have the steps listed out here. So complete the square is the first part. We're not solving anything. I just want you to get this whole idea of what number do I need to add to complete the square and what on earth am I talking about? Okay. So here I have an x squared plus a bx expression. And I basically want to fill in plus what would give me one of these perfect square situations. Okay? So in order to figure out plus what, it's like we're doing the opposite of what we did before to see if we could use it. First thing you do is you take 1/2 of b. So this number 6, that's your b term, right? That's the bx. So I'm going to take half of b, so that means I'm going to divide 6 by 2. And then I'm supposed to square that result. So I want to do 6 divided by 2 squared. Alright, so 6 divided by 2 is 3, and 3 squared equals 9, right? So that means if I add 9 here, I've now got a perfect square trinomial that I can rewrite. So step number 3 says, add the result from step 2 to x squared plus bx. We just did that. And then we're going to factor the resulting expression. So to factor the resulting expression here, this x squared stays the same. Well, not stays the same, but this is my expression I want to factor. The square root of x squared is x. The square root of 9 is 3 squared. So this will give me this because this is a perfect square trinomial. Let's try another one just in case it's like, what are you talking about? So remember, this means a negative 9x. So notice there's no plus c, so I want to know what can I add here to make this a perfect square. So the steps are you take b divided by 2 and square it. And yes, I did this so you can see there are decimals and it's okay. When you take the quantity of negative 9 divided by 2 squared, you don't get a negative. You get a negative if you don't put parentheses around it. You need some parentheses around it. You should get 20.25. So that means if I add 20.25 to this, that gives me my perfect square trinomial. So here we go. Alright, so the square root of x squared is x. And maybe you're wondering, well, what am I supposed to put in here? You're supposed to put in here the square root of 20.25, right? Well, the square root of it's going to be what you got before you squared it. So what's negative 9 divided by 2? That's negative 4.5, right? So this is going to be negative 4.5. So this little piece, before you square it, tells you the number to place there. And this, of course, is squared. So moral of the story, divide b by 2. That actually will give you the number that you add here. And then you would square that to get the c term. Let's try some, shall we? I know, you're probably thinking, whoa, what on earth? We'll do lots of practice in class. It'll be fine. Okay, so solve by completing the square. Now remember, the whole point of this one is we want it in the form of x squared plus bx equals something, and then we're going to replace our c with the number we pick. So you want this to be in the form of x squared plus bx equals d before you begin doing this. And right now, it's not in that form. I need this -3 to go away. So I'm going to add 3 to each side, and now I have x squared plus 8x equals 20. So this is the form we want. Now what we want to do is we want to figure out what number can I add to this to make it a perfect square trinomial. So I'm going to take x squared plus 8x plus something. Okay? To find out the something, you take b divided by 2 squared. So 8 divided by 2 is 4. 4 squared is 16. So that means I'm going to add 16 here. But do you see how you just added 16 to this side of the equation? Do you know what you have to do? Yep, you have to add 16 to this side of the equation also. Because whatever you do to one side, you have to do to the other. It's just like my children, Ellie and Ethan. If I give one a cookie, I better give the other one a cookie too. Alright, so over here, I'm going to rewrite this as its perfect square. And it's going to be x plus whatever b divided by 2 was, right? So b divided by 2 is 4, and it's squared. Over here, we have 36. Now at this point, I'm hoping that you see this and you think, wait a minute, these are the ones that we did in the last lesson in 9.2. Exactly. Right now I have an x squared equals d equation, and that was our goal, because these aren't too bad to solve, right? In order to figure out what x is, I need to get rid of this squared first, so I'm going to take the square root of this side. And if I take the square root of this side, it means I also need to take the square root of this side. And remember that there are positive and negative square roots, because 6 squared is 36, but the quantity of -6 squared is also 36. So the square root of x plus 4 squared is x plus 4. And the square root of 36 is either a positive or a -6. Now we got to break it up. X plus 4 can equal 6. X plus 4 can equal -6. Subtract your 4 from this one, and we get x is 2. Subtract your 4 from this one, and x is -10. So this one has 2 solutions. Wow, piece of cake, huh? I know. Yeah, I know. This is probably going to be your least favorite method. I'm so sorry. But maybe you'll start to like it later on in some of your other higher math classes that you have, and you'll see the whole purpose for it. When you're first introduced to things, they're kind of tough. After a while, this might end up being your favorite because there's so much algebra in here, and a lot of us love solving those equations. Okay, take a look at this one. I would want to use completing the square for this one because I see it's in x squared plus bx equals d form. That's great. So my step 1, I need to figure out what can I add to this side to make it a perfect square. And remember, whatever I add to that side, I need to add to this side too. I'm going to keep change this. So in order to figure out what number to add here, all I have to do is I have to take my b divided by 2 and square it. And that gives me what to add. So a -6 divided by 2, that's -3. And -3 squared, quantity of -3 squared, gives me a positive 9, right? So I'm going to add a 9 here, I'm going to add a 9 here. Now I want to rewrite this as its perfect square. So the square root of x squared is x. And remember, to get what number I'm supposed to add here, it's whatever I got before I squared this. So a -6 divided by 2 is a -3. And 27 plus 9 is 36. Or maybe you remember the rule that if it was a negative and a positive, this was subtraction or adding the negative. But it's basically whatever you got when you take b divided by 2. That's the other term right there. Okay, so now I want to get rid of this squared. So I'm going to take the quantity of x plus -3, take the square root of that, and I want to also take the square root of 36 over here, which we just did. That's a nice one. I try to be as friendly as I can with these numbers. All right, so the square root of the quantity of x plus negative 3 squared is x plus negative 3, and the square root of 36 can either be a positive or a negative 6. So we've got two equations. X plus negative 3 can be a positive 6. X plus negative 3 can be a negative 6. Solve it. X can be 9. X can also be negative 3. Now, if only there weren't a back, I know, we'd be done. You'd be like, oh, yay. But I don't think just 2 examples of this are going to cut it. So let's do a few more. Turn your paper over. Get all your moaning and groaning out. I know, me too. All right, here we go. Here's another one. Now, remember, we need this to be an x squared plus bx equals d form before we start. And with this one, it's not in that form yet. I need this 3 to move it, because I like to move it. I know every time I say move it, that song pops into my head. All right, so I'm going to have x squared plus 12x on this side, and over here, 1 minus 3 is negative 2, right? Okay, now I have to figure out plus what? I'm going to write it down here because I did not give myself enough room. Okay, so to figure out plus what to make this perfect square, I'm going to take my b divided by 2 and square it. So 12 divided by 2, that's 6. 6 squared is 36. So that means I need to add 36 to this side, and I need to make sure I add 36 to that side as well. Whatever you do to one side, you have to do to the other. So I can rewrite this one as a perfect square. It's x plus, and when you took b divided by 2, it's 6. So this right here will be written as that. And negative 2 plus 36, that is 34. So this one's not going to be quite as friendly, but it's still doable. Don't worry, you'll be fine. All right, so I want to get rid of this squared, so I'm going to take the square root of x plus 6 squared, and I want the positive or negative version of the square root of 34. Okay, so the square root of the quantity of x plus 6 squared, yes, it's x plus 6. Okay, now, plus or minus. There's 2 different ways to do this. We can do the approximate, or we can do the actual. In the back of your textbook, when you're searching for the answers, it's always going to give you the actual and keep the root. When we get to the quadratic formula, I'm going to be using the approximate, so I'm going to have you do the approximate for this. With 34, if you wanted to do the actual, 34 can't be broken down anymore, so you just leave it like that. So instead of, and I'll show you at the end what it would look like, but I just want you to take the square root of 34. So go second x squared, type in your 34, and hundredths place will be good for me. All right, so I get 5.830. To round to the hundredths place, the 3 I'm going to leave it alone. So I have a positive or negative 5.83. Whoa, my pen just jumped out of my hand. And I know this is a decimal. We're going to solve it the same exact way. X plus 6 can equal a positive 5 83/100. X plus 6 can equal a negative 5 83/100. And we solve it. So I'm going to subtract 6 or add negative 6. 5.83 plus negative 6. Yep, negative 17/100. When you add your negative 6 over here, we get negative 11 and 83/100. So these are my 2 approximate answers, and you can use the squigglies. I'm not going to mark you down if you don't, but those aren't exact, right? They were rounded. The way the back of the book is going to have this listed out for you, and you'll see this in other courses this way. You could also, at this point, have said, I'm not going to do this for every single one. I'll do it for this one, though. I could have said x plus 6 equals the square root of 34, and I could have said x plus 6 equals the negative square root of 34. So with this one, you would have had to subtract 6, so x would equal the square root of 34 minus 6, and if you subtract 6 here, x would equal the opposite of the square root of 34 minus 6. So that's another way you could see it written. Don't be alarmed when you see that. It means the same thing as this, because if you were to evaluate that, that's what you would get. Okie dokie. All right, next one. Okay, this is not in the form I need it to be in. And my step 1, let's get this in the x squared plus bx without anything being added first. So I'm going to get rid of that 10. So 2x squared plus 4x equals 48. Now, in looking at this, I don't know if this is red flagging anything to you, but when I look at this, I think, man, there's a GCF. I should really get rid of that to make these numbers more manageable. Whenever you look at an equation, if you see that there's something that can be factored out, that you could get rid of, that you could divide by, do it. It'll make life easier. So 2 goes into all of those, right? I'm going to divide everything by 2. 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. 48 divided by 2 is 24. Alright, so much easier to work with. None of the other equations that we had actually had anything that we could factor out. This one did. So, and it's gone now because I've divided both sides by it. I didn't bring it out to the front and only do it to one side. I divided both sides by that. And you could have done it first up here if you wanted to. That would be fine. Alright, so x squared plus 2x plus what? And I need to add that same amount to the other side as well. So to figure out what to add to make this a perfect square, I'm going to take the b, divide it by 1, and square it. So 2 divided by 1 is 2, and 2 squared is what? I'm sorry, 2 divided by 1, yeah. I only divided by 1 instead of divided by 2. That's what I did wrong. Like, what's going on? So 2 divided by 2 is 1, 1 squared is 1. Sorry. And 24 plus 1. I have to do the same thing. Maybe you're seeing 24 plus 1, you're like, yes, finally a nice whole number. Okay, let's rewrite this as its perfect square. It'll be x plus, when you took b divided by 2, right? We got 1. So there's that. And then 24 plus 1 is 25. Now I want to get rid of this squared, so this is just like section 9.2. I'm going to take the square root of the quantity of x plus 1 squared. And then I'm going to take the positive or negative square root of 25. So, the square root of the quantity of x plus 1 squared, say that 5 times fast, is x plus 1. And the square root of 25, it's either a positive or a negative 5. Now we get to break it up. So x plus 1 can be positive 5, x plus 1 can be negative 5. I'm going to subtract 1 to get x alone, and subtract 1 again to get x alone. And I get 4 and negative 6. And again, you could check this in your calculator. You could get this in standard form from the beginning and move this 58 over here, type it in, see if you get the same answers. Yes, but you do need to be able to show me all these steps. I know, it's crazy, but true. Alright, we have one little math story for this, because everything has to have a story. You throw a stone from a height of, and hopefully no one was standing underneath there, hopefully it wasn't from a tall building, hopefully you were just, standing on the beach, nobody was there, you threw a stone. You threw it from a height of 16 feet with an upward velocity of 32 feet per second. The function h equals negative 16t squared plus 32t plus 16 gives the height h of the stone after t seconds. When does the stone land in the water? Okay, so first off, the fact that you're throwing a stone, that's great. They give you the equation though. H equals negative 16t squared plus 32t plus 16. So that's it. H is height, t is time. When does the stone land in the water? So I'm hoping you're picturing, you're standing here, you throw it, and it goes up, then it comes down. I want to know when is it going to hit the water. So let's see here. What do we do? What do you think? At what height will it hit the water? I'm just pretending that I'm in the classroom right now. How high is it going to be when it hits the water? Hopefully you're saying, well, won't it be at 0 feet? Because the water's kind of like, look at it as the x-axis. Yes. So basically what I'm asking you is, when is the height 0? So to figure out when the height is 0, after how many seconds, all you have to do is plug 0 in for the height. So far, so good, I hope. Now, in looking at this one, I know before I switched it around first, but this time, let's go ahead and let's simplify this up a little bit. Is there a GCF? Can I simplify this? Yeah. I can divide this side by 16, can't I? You know what I would like to divide it by? I would like to divide it by a negative 16 so I can get rid of this negative right here. So I'm going to divide both sides by, well, 0 divided by negative 16. I can write it. It's fine. Okay, we know it's 0. Negative 16t squared divided by negative 16, that would just give me t squared. And then 32t divided by negative 16, that's going to give me a negative 2t. And 16 divided by negative 16 is going to give me a negative 1. So in looking at this, if we're using this whole completing the square business, this is probably a lot easier to deal with than that, right? That's the purpose of it. Okay, so with this, I now need to have this x squared plus bx by itself. So let's add 1 to each side, and we're working with it backwards. It's okay. I'm allowed to have the x squared plus bx over here. It's okay. All right, so now we're set up to go ahead and figure out what number can I add to each side, and I put on the other side because it's addition, order doesn't matter, to make this a perfect square. So all I have to do to figure that out is I have to take half of b squared. So remember, b is a negative 2, so I would take negative 2 divided by 2 squared. And negative 2 divided by 2 is negative 1. Negative 1 times negative 1 is a positive 1. So I'm going to add 1 here, and I'm going to add 1 here. So this means that 2 is equal to, and to figure out what the perfect square is, I take t and then whatever we got when we took b divided by 2. And negative 2 divided by 2 is negative 1. Okay, now I want this squared to go away. So I'm going to take the quantity of t plus negative 1 squared, take the square root of that, and then of course I need to take the square root of the opposite side as well. Okay, so the square root of t plus negative 1, the quantity of t plus negative 1, is t plus negative 1. And here I have plus or minus the square root of 2, right? Well, let's give an approximate, so let's find the square root of 2. Second x squared 2 is 1.41, about. So I'm going to write plus or minus 1.41. Okay, at this point we need to break it up. I'm going to move over to the other side over here to give myself some more space. And I'm going to kind of flip it around at this point, if you don't mind. I'm going to say t plus negative 1 can equal a positive 1.41. And t plus negative 1 can equal a negative 1.41. Let's see if we can still, yep, we can still see it on the camera. Okay, so let's solve both of these. I would add 1 to each side, and the time is equal to 2.41 seconds. And here, when I add 1, I get the time is equal to negative 41/100ths of a second. Now, I know that it looks like there's two solutions here, but last time that I checked, we could not go back in time, right? Time can't be negative. You can have a bad time, but time can't be negative. So there's just one solution to this, and the solution is after about 2.5 seconds, I would say, that's when it happens. That's when the stone lands in the water. So it all happens very fast. Hopefully nobody saw you and you can run away with all your little stones that you're throwing in the water. Not at people. All right, see you tomorrow.